Could you check your mic, Akzent? I think you're muted.
Can you hear me?
Perfect, perfect. Go on.
Alright. So let me repeat. So these variables or whatever um, the memories which we have in our stacks, those are volatile, which means once we close our program, so these variables, they are known as volatile. So when we close our program or when we stop running our program, all of these gets erased, right? Like they just go away from the memory. You don't have any permanent storage. So to have this permanent storage only, we have multiple ways. So one of those is file handling. So what are the other ways? So we know one way is file handling. File handling. And the second way is known as database. So you all might have heard SQLs or database. So that is also a way where we can store our data permanently. So as of for now, we won't be learning databases. We are going to learn file handling in Java. So let's see how to use file handling in Java. So when it comes to file handling, we have to know two things, right? First thing is how to write, and then how to read what we wrote, or like how to read data from a file. So for these, to write and read, we will be using two classes mainly. To write, we'll be using a class called file writer. So these packages are available in java.io. So when you import java.io, you'll be getting all these packages by default, okay? So IO stands for input and output. And to read, we'll be using something called file, a class called file. So let's do it. So at the first, we are going to try writing something to a file. To do that, first of all, I had to create object. So why do we create object? Since Java is object oriented, everything works based on an object and classes. So first of all, I'm going to create an object of file writer. So file writer, I can name this file as anything I want. This is just a reference name. I'll keep it as my file equals new file writer. So within this parenthesis, what we give as a parameter is known as a file name, or the name which you want to be, like the file name which you want to keep for your file. So I'll keep it as my test file.txt. So guys, make sure when you all write this, you all also have to mention the extension of the file, or else it's gonna throw error. The second of thing I forgot to do. The first thing is whenever we open a file or whenever we are gonna use file handling, what we have to do is use error handling as a catch method. The reason is most of the time when we use file handling, there's a lot of chances where it might throw error, our program might throw error. So the best way is to surround it by a try catch mirror. So you all can see I just used a try and a catch block. So if there's any error while creating the file, then it would be handled by this catch block, okay? So now I have created my file, right? So I have to see if I can see my file. So let's run this program once and see if we can see the file. So it's building. And yes, you all can see there's a file called my text file, right? See, it's creator. Though there's nothing inside it, still it's creator, okay? So the next off, we are gonna see how to write data inside our file. To write data inside our file, it's nothing complex. We are gonna use a built-in method called write. So first of all, we'll be calling our object name. So the object reference name is my file, right? So we'll be saying my file dot write, and then within the parentheses, we can say what we want to write inside our file. So let's try writing hello world. So I say hello world, and then I'm going to run my program. Yep. So it says the code exited, so it wrote and then the program ended. So now if I go to my text file, why? Oh wait, I didn't close the file. My file got closed. Let me check now. Writer, writer. Yes. Hands-on text is filter store. Oh, by the way, if y'all have any questions, make sure y'all raise your hand, or else I won't know whether y'all have any questions or not. Give me a minute. Okay, so let's check this writer or close. So let's run the program now. And now y'all can see we have the text which we wrote here, hello world. So this is simple as it is. You don't have to do anything else. It's just you use this method called write and you can just write any data you want. So you all have to know one thing. So whenever we write a file, we write something into our file, and when you open it, you all can see the cursor blinking right here, right? Which means the cursor has ended right there. So if you want a new line, then you have to say that you want to go to the next line. For example, I'm going to copy this line and I'm going to paste it. So when I run this code, the hello world is going to stay right next to each other. It's not going to go to the next line. The reason is this write method by default has something similar to the printf or the print in the same line. So if you want it to go to the next line, you all have to say /n. So in that case, it would be going to the next line. So let me run this, and here it goes to the next line. So y'all also can print something inside your variable, or y'all can create a variable. So let me do this. So I'm going to create a variable. Let's say string greetings equal welcome. So if I want to print something which is stored inside my variable, I could simply say my file dot write and then pass in the variable name. So it's going to be greetings. So when I save this and when I run this, oh wait, I missed a token. Yeah, that's it. Yes, it works perfectly. So you all can see welcome and then hello world. Once again, I missed a /n. So you all can say it like this, plus concatenate it with the /n backwards. Yes. So now if you run, yes, that's it. So this is so simple. This is how you write data into your files, okay? So that's all in file write method. So let's say how to read something from a file, and maybe y'all can like read and do some calculations or something similar, okay? So to read something or read a data from a file, we'll be using another class called file. So this file class is something similar to file writer, but then again, this file class is just going to store your path. What I mean by path is this text file has a path, right? So when I say copy path, so this text file has a unique path, and when it comes to different machines like Windows, Macs, it's going to be different ways. It represents the path, right? So to store these paths in a unique way, which all the programs can handle, we have this class called file. So this file class, the file class in Java, is going to save the path of this certain file which you're mentioning. So again, the syntax is going to be similar. You're going to say file, my file, and create object out of it. So after that, within the parenthesis, you have to say the name of the file. So since my file is in the same, in the same directory, I can just say the name. If not, you all have to say the path and the name. So I'm going to say my test file dot txt. Again, you all have to mention the extension. Okay. So now let's try running this. Why is it throwing error? Delay Java is correspond. Okay. Let's run it by a normal block. X run try catch. Yep. All right. So now we have linked our file, but how can we read data by using this? Sorry. So how can we read data by using this? So to read data, we'll be using our scanner class. So we have used our scanner class to get inputs, right? So we'll be using this same scanner class, but this time I'm gonna say my scanner, oh wait, my scanner equals to new scanner, and within parentheses, so when we are getting a user input, we'll be using a class called system.in, right? But this time we are going to read a data from a file, right? So what we are going to say is we are going to give the object which we created using the file, which is my file, as a parameter. Oh, sorry. My file, Control C, Control V. All right. So what we are saying is we are saying our scanner class, scanner object, to use this file to read the data. Okay. So once we are done with this, we have created two objects. One is the file object and then the scan objects. Okay. So once we are done with that, we can use a method called, there are two methods, which is known as next line and has next line. So why do we need it? First of all, when it comes to your coursework, they ask you all to create a file. I mean, store all the student details into a file, right? And during a certain time, you don't know how many lines are inside your file. There may be 50, or there may be 100, or even less, or just one line. So how do you know the number of lines, or how do you know the number of data inside it? To check if there's any data inside it, we use a method called has next line. So there's this method called dot has next line. So this method would be returning a boolean value saying true or false. So if it's true, which means there's some data inside your text file. If not, it means there's no data inside your text file. So let's check if this is working. So I'm going to use a if statement to check if we have any data inside our file. So I'm going to call our scan object, the scan object which we created. I'm going to say my scanner dot has next line. So if it's true, I want it to print sort. Let's say we have something inside. Else, let's say so the text file is empty. Okay. So now at this moment inside our text file we have 3 lines, right? So this condition becomes true, right? In that case it should be printing we have something inside. So let's see if this is working. So I run the code and then it says we have something inside. So let's delete this, save it, and then try again. See, it says my the text is empty, or text file is empty. File is empty. So this is how you check if there's any content inside your text file. So once we know there's some content or there's some set of lines inside it, we can use the read method and read all the data inside our file. So let's try reading the data now. So I'm going to have the same thing for the else part. So inside the if part, I'm going to change it. So I'm going to say if there's any data, so if there's any data existing inside my text file, then I want to read that data. So it's going to be something like this. I'm gonna say string, since it's a string, I'll say string data equals my scanner, and then next line. So this method is going to read the data in the first line. So let's say we have my hello world. So it's gonna read whatever the data is inside the first line of the text file. Okay, I'll say next line, and then let's try printing the data which we read. Data. So see, it says hello world. So why do I say it's going to read only the first line? Let's try adding more lines here. So welcome to the welcome. Let's just keep it as welcome, and let's run this code. Still, it only prints hello world. It doesn't it doesn't print the welcome part, right? The reason is has next line or the next line method. So you all might have used the same next line method in while using the scanner class, right? To get user inputs. So next line is only going to read the first consecutive line or the line which is right after running the program. So it would be only taking the first line. So if you want to run it again and again, then we have to loop this, right? We have to loop this condition, or we have to keep on running this part, right? This set of these two equations or these two instructions, right? So how are we going to do it? So we can use a condition, either a for loop or else a while loop. I would prefer using a while loop because we already know our condition. Our condition is if we have next line in our text file, then we have to read it. If not, we don't have to read it, right? So I'm going to use a while loop here rather than using a if-else statement. So we can remove this. Now I'm going to say, while there's some data inside our file, I want to scan that data and then print the data. So what happens is when the program runs, uh, at the start, it's going to check if there's any data inside our file. It checks if there's any line inside our file. There is a line. So then it's going to use the scanner method, the next line method, and it's going to scan this text or the data, and then it's going to print it. Afterwards, the while loop would be running again. So when it comes here again, it's going to check if there's another line. So now the cursor would be here, and it would be checking if there's another line of data. Yes, again it's going to be true, right? Since we have data, it's going to be true. So then what happens is, again it's going to read the data and then print the data. So let's run it and see if it's working. Yes, so you all can see it's working. So like this, we can take our data, we can assign them, we can print them, or we can even calculate it. So let's try doing something like a calculator or calculating app. So I'm gonna say I need the answer for 2 plus 2 here. Okay, so inside my text file I only have this thing. I just have 2 plus 2. Okay, that's it. So what I'm going to do here is, while there's a line inside my file, I'm going to scan the line. So I'm going to use the scanner method, and I'm going to scan the line. And first, let's try to print it. So after printing, it says 2 plus 2, and it's just a string. It's not an integer or anything. So now what we do is, we are going to take our data. This is our data, right? We are going to split it. So why are we splitting it? The reason is, we want 2 as an integer and this 2 as an integer, and then use the plus operand, right? So in that case, we have to split the string into 2. So what I'm going to do is, I'm going to create a array, a string array. The reason why I'm creating a string array is, whenever we split a string, it's going to return a string. Okay, so I'm creating a string array. I'm going to say let's say numbers, and I'm gonna say it's going to be data dot split data dot split by plus operands. So at the moment it's throwing an error. The reason is we haven't mentioned data outside the while loop. So let's initialize this here and then remove this. What's the problem now? Might not have initialized. Yep. Let's keep this. All right. Now the error is gone. Yep. It's throwing error, but still there's no error. So after splitting the data, let's try printing what we got. So I'm gonna use a, let's use print statement, numbers. I want to print the 0th index and whatever the number inside the first index, numbers, index 1. So how do I say there's only going to be 2 items? The reason is when we split this by using the plus sign, it's going to return only 2 items, which is 2 and 2. There's nothing else in this text file to return. So let's run it and see if it's working properly. There's some error. Danlang error. Oh, maybe the regex. Probably we might have to use a escape key. So let's change it here to a comma for now. Okay, so I'm going to use this, and when we run this, now it would be returning this. So wait, we don't want to print this, right? So now you all can see inside our numbers array, inside the 0th index, we have a string called 2, and inside our index 1, we have another string called, with the value 2. So now we can perform additions or subtractions, but then again, before doing that, we have to convert this string to an integer. So to do that, we'll be using integer.parseInt. These are basic things which we learned in our first few weeks. So I'll be saying 0, and then I want to add it with the integer dot parseInt numbers array, the first element. So again, take your time and look into this. What we are doing is we are taking the 0th element inside our numbers array, and then we are converting it to an integer. After that, we are taking our first index and converting it to an integer, and then we are using a plus sign. So now when we run this, we get the output as 4. So this is how you read a complex data and then split it, or y'all can turn the piece of data into a meaningful information. So note this, guys, for your coursework, y'all have to use split functions, and y'all have to find a way to keep your data organized. So that's all about file handling. I don't think there's anything else complex in this part. If y'all have any doubts, y'all can reach us out. So the next one. So as the next part, we are going to learn bubble sorting. Okay, so let's first try to understand how bubble sort works. I think I had a table over here. Okay. Can I erase this? No, let me create another one then. Okay. So why do we need a sorting algorithm? If your array or if your set of data is not in a particular order, ascending or descending, then you might have to sort it, right? And there are methods, but we are not allowed to use inbuilt methods to sort. So as a beginner stage, we have to learn how to sort our arrays or our data. So bubble sort is one of the methods which we are learning. So let's see how bubble sort works. So let's take that we have a on let's say we have some random numbers which is not sorted. 9, 5, 6, 2, so on. Okay, so we have just think this as an array. Let's just consider this part as an array. So we have an array of numbers 9, 4, 6, 1, 7. So now what we want to do is we want to sort it in ascending order. So if you sort it in ascending order, it's going to be 1, 4, 6, 7, and 9, right? So we want to turn this to this. So let's see how bubble sort algorithm works. So in bubble sort algorithm, what we do is we take the first or the first element and then we compare it with the next element, which is 4 here. So we check if our first element is greater than the second element. So if it's greater, if it's true, then what we do is we swap this, like we change the indexes or we change the position of this second element and the first element. Okay, so let's try to understand it way better. So we are now what we have in our left, so let's name it as left and right, left and right. So the value in our left position is 9, right? And in the right side we have 4. So out of this, which one is the greatest value? 9, right? So which means the condition is true. So if it's true, it's going to swap its value. So in that case, 4 would be coming here and 9 would be staying here. That's how bubble sort works. So after that, again, it's going to compare itself. It's going to take the second item or second element of the index and it's going to compare it with the third element. Now it's 9 and 6. So 9 is again greater than 6. So it would be returning true. And then what happens is it's going to switch its places. So 9 comes here and 6 goes here. So let me erase this part. Oh, wait. 9, and now 9 moves this side and 6 comes here and 9 switches here. So now we are in the third element. So staying at the third element, wait, let me clear this up. Yeah. Now we are at our third element. Again, what happens is it's going to take 9 and compare it with the next element, which is 1. Again, the statement returns true, so it's gonna swap its positions. So let's take this, cut it off. 1 comes here and 9 stays here. Once again, still we are not in the end of our array. It's gonna happen once more. So 9 is comparing itself with 7. 7 is the largest number, so it's going to swap its positions. So 7 comes here and 9 comes here. So now we all can say in the first iteration or in the first round itself, we have our largest number in the last position. It's like it's already sorted. So we don't have to look into this again, right? Because it's already sorted according to the ascending order. Okay. So again, what happens is we are going to run this or we are going to run this set of instructions which we had in the previous step one more time. So we are going to take the first element and compare it with the second element. Now the first element is 4 and the second element is 6. So comparing that, 4 is not greater than 6. So what happens is 4 is going to stay in the same position. The reason is 4 greater than 6, the statement returns false. So if it's false, we are not going to swap. Okay, we are only going to swap if it's true. So let's try swap only if true. Okay, so now we'll be moving to the second element. We'll be comparing 6 and 1. So we have 6. Let me clear this part. We have 6 and we have 1. 6 greater than 1. So this statement is going to return us true, which means we have to swap it, right? So we're going to swap 1 and 6. So after swapping 1 and 6, now we are going to check it with the next number, which is 7. So we are going to check if 6 is greater than 7. So this statement is going to return false, which means we are not going to swap anything. We are not going to swap the elements. We are going to leave it as it is. So we already know in the first iteration itself, we decided that our last element is sorted. So during the first iteration, we know this one is sorted. And during the second iteration, we are sure that the last two elements are sorted. Now we can say these two elements are sorted. Though it looks like this one is also sorted, again the algorithm would be running the set of instruction again and confirm that it's sorted. Until then, it won't be considering it as sorted. Okay, so what happens now is in binary sort, we'll be running the same set of instructions again. We're going to take the first element, compare it with this second element. 4 is greater than 1, it's true, so it's going to swap itself. 1 comes here, 4 comes here. 4 is going to check itself with 6. It's false, so it's going to remain the same. So 1, 4, 6, and you know the rest is already sorted. So we can write 7 and 9. By this time, we know our first 3 elements are sorted. So these are sorted. And once again, the algorithm would be running the same set of instructions again. It's going to check if 1 is greater than 4. If it's greater than 4, it's going to swap. It's not greater than 4, so it's going to leave it as it is. So after this step, your set of array is sorted. This is the sorted array. So this is how bubble sort algorithm works. So let's take another example. Just filled out the table. Never mind. Let's just look into it. So we have an array starting with 5, 9, 8, 1, 6, 7, 3, and 4. We want it to be sorted. So at the first place, we are going to compare if 5 is greater than 9. No, right? It's going to return false. So we are going to keep this as it is. And then we come to our second element. We are going to compare if our second element is greater than our third element. It's true. Since our second element is greater than the third element, we are going to swap its position. So 8 comes here and 9 stays here as temporary. Okay. So after that, we are going to check if 9 is greater than 1. So since it's true, we have to swap it again. So after that, what happens is 1 would be coming here and 9 would be here temporarily. Again, the algorithm is going to check if 9 is greater than 6. It's true, so it's going to assign 6 here. It checks if 9 is greater than 7. It's true, so it's going to assign here. It checks if 9 is greater than 3. It's true, so it assigns a value here. It checks if the 9 is greater than 4. Again, it's true, so it's going to swap its position. Now, at the end of the first iteration, you all can see we have sorted our last element in our array. So this one is already done. We don't have to check it again. It's going to be the same. Okay. So in the second iteration, we are going to run the same set of instructions again. So we're going to check if our first element is greater than this second element. So is 5 greater than 8? No. So it's going to leave it as it is. Is 8 greater than 1? Yes, it's true. So it swaps. Is 8 greater than 6? It's true. So it swaps. Is 8 greater than 7? It's true. So it swaps. Is 8 greater than 3? It's again true. It swaps. 4, it's obviously true. And at the end, we come to this position where 8 is not greater than 9. So it remains at it is as it is. So now by the end of this second iteration, we found out that our last two elements are sorted. Likewise, during each and every iteration, we'll be sorting out the last ith elements. Okay. So at the end, you'll be having your sorted array. So this is how sorting algorithm works. So let's try to implement this in Java and see how it works. So let's create an array. Let's create a numbers array. I'm gonna say int numbers number equals let's say, let's use the same example which you use here. 94617 94617. Okay, yeah, we have created our numbers array. After that, I'm going to print the elements inside our array. So I'm going to use a for loop. This is just to see if our array is sorted or not sorted. So I'm going to say for integer I in our numbers array, print I. So I don't want to print it in a new line. I'm going to print it in the same line with a space. All right. So I'm going to say some print before sorting, and I'm going to have the same thing after sorting. So let's try to implement this sorting algorithm. So you all can see here, we'll be running this set of instruction multiple times, not just once, but we'll be running it again and again. And once again, every time, so during each and every iterations, we'll be checking if the next element is greater than the previous element. And we'll be swapping it until we take the largest element to the the last index, right? So there are two for loops working behind this. The first for loop will be managing the number of iterations or the number of times we have to check or run this set of instructions. And the second for loop is going to take care of switching elements or checking if each and the first element is greater than the second element. So let's try to code this and see. So we are going to use two for loops for this. It's going to be a nested for loop. I'm going to say int I equals 0. And I'm going to say while I is lesser than, it should be lesser than our numbers array dot length. So this is our terminating condition, and I plus plus. Or else let's do one thing. Let's assign the length of the array to a variable. Let's say integer size equals number dot length. Oh wait, is it size? Size, no. Number dot length. Oh, it works. So here we can say while it's lesser than this size. Okay, so inside this we need another for loop. So we're going to say for int j equals 0. Once again, we want to run this condition while j is lesser than size, and then we want to increment the j's value. So inside our nested for loop, what we are going to do is we are going to take each and every element and check if it's larger than the next neighbor element. So you're going to take numbers array. Inside our numbers array, we are going to take the jth index, and we're going to check if it's greater than numbers array the next neighbor. So the next neighbor is going to be j plus 1, right? So I'm going to say j plus 1. So if it's greater, then what we have to do is we have to swap it. So that's what we want to do, right? So we have to swap it. So how do we do the swapping part? So to do the swapping part, what we do is, let me show it here. So let's say we have a array like this for oh wait, 1 and 2. To swap these two, what we do is we take the value of the first element and assign it to a temporary variable. Okay, so after assigning it to a temporary variable, what we do is we say the next element is going to equal the next element, sorry, the zeroth zeroth index value. So index value is going to be our next element, which is going to be 1. Okay, so what we have done here is we are saying the first or the zeroth index, we are taking the zeroth index value and assigning it to a temporary variable. After that, we are saying the zeroth index value is going to be our the next element or the neighbor element. So how do we say that? We can just say zeroth index equal the first index or the first index value. First index value. Afterwards, so now we all can see the zeroth position would be changed by the corresponding neighbor value. So it's going to be 1. Now it's 1. So now again we have to change this one's value, right? And this one's value is stored inside our temporary variable. So what we can say is we are going to take our first index and say the value of first index is going to be the temporary variable or the value of the temporary variable. So this is how we perform swapping in Bubblesort when it comes to Bubblesort. So for this we need a temporary variable. So I'll create an integer temp and I'll leave it as it is. I'm gonna say the numbers, oh no, I should be saying temp is equal to the current position of numbers, which is going to be j. And then I'm going to say number j, the jth index is going to be the value of its neighbor, which is going to be j plus 1, right? So j plus 1. And after doing this, we have to reassign the, so at this point, at this line, what we are doing is we are assigning the zeroth index value, the first index value to the zeroth index position. So after that, what we have to do is we have to again change the value of the temp or change the value of the first index to the temp variable, right? So for that, what we do is we say number j plus 1 is going to be equals to the temp variable or the value of the temp variable. So by doing this, we have swapped our positions or values. So let's try running this, and this code should be throwing an error. If I'm correct, it should be throwing error, and the error is going to be index out of bound. Yes, the reason is you all can see we say j plus 1 every time when we check the value, right? So when it comes to this position, or when j turns to 4, since the size is 5, the maximum value j can go is 4, right? So when j's value is 4, and when we are trying to fetch a index which is j plus 1, which is 5, then it's index out of bound, right? What I'm trying to say is in our array we only have 6. Let's take this. So the size of the array is 6. Oh, sorry, the size of the array is 5. Okay, so the last element, so the index is going to be 0, 1, 2, 3, 4. So when it comes to this index and when it comes to our condition, which is nums j, we are checking if it's greater than the next element, which is num j plus 1. Num, let me move a bit. Nums j plus 1. So now at the last, when we are at the last iteration, the j's value would be 4, and we are checking the value of the fifth element, which is not existing. So then it would be throwing us a error, which is index out of bound. So how do we arrange, or how do we handle this error? So what we are going to do is inside our second loop. So the first loop is going to check the number of times we have to iterate, and inside our second loop we are going to say we are going to say -1. So by saying -1, we are going to stop our condition, or we are going to stop this at this point itself. So when j is 3, it's going to stop. So it's going to check when j is 3, it's going to check the value of the third index value and compare it with the fourth index, and if it's true, it's going to swap. We don't have to check the next element because there's no next element, and there's no point of checking it again. Okay, so we say size -1 for the inner for loop, not for the outer for loop, for the inner for loop. So when we run it now, so it says before sorting. Oh, let me give a print line. So yep, this will work now. So it says before sorting and then after sorting. So before sorting it's 94617, after sorting it's 14679. So once again, there's something we could do way better than this. The thing is time complexities. So hold on. So every algorithm, so when it comes to sorting and searching, not only sorting and searching, when it comes to any algorithms which you all create, everything has a time complexity. So time complexity is the number of time or the additional time it takes to run another extra step or one more extra step in that algorithm. So when it comes to the time complexity of bubble sort, we say it as log, it's going to be O(n) square. We say it as O(n) square. Oh, we don't have power, so let me say O(n) square. So this is the time complexity of bubble sort algorithm. But what we have done here is way, the algorithm which we have done here is something similar to like wave version, not even bubble sort. The reason is, I told you all right. So during, like at the end of each iterations, we can say our last element is sorted. Like in the first iteration, we can say the first element is sorted. In the second iteration, we can say the last two elements are sorted. The third iteration, we can say the last three elements are sorted. So if it's sorted, do we have to check the conditions again and again? There's no reason to check, right? And every time when you run this condition, there's going to be a memory cost. So when it comes to like real world problems, or when y'all are solving with real world problems, there would be a real cost, like the data cost or the cost to fetch the data and stuff. So to reduce it, what we say is, we are going to say the size -1 and minus I. The reason why I say I is, after the first iteration, the i's value is going to turn into 1. So after the first iteration, we know our last item or the last item would be sorted. So then we don't have to even compare these two, right? We can stop it at this point itself, right? So that's why we say I. So the i's value is going to be changing during each and every iterations. So during the after the first iteration, so at the end of the first iteration, we don't have to compare these two. In the second, we don't have to compare these three likewise. So that's why we say size minus I minus 1. Let me go here. So you all can see we have told the condition is going to be size minus I minus 1. Once again, if you run the program, there's going to be zero difference. It's going to be the same. But then again, there's a memory efficiency running behind the scenes. Okay. And that's why we say size minus I minus 1. Okay. So that's all about bubble sort as well. So we are done with two topics, which is bubble sort and file handling. And as the last part, we are gonna learn arrays. So I don't think you people have anything to do with 2D arrays. So sort of teaching you all object arrays. So object array is something you all be needing. So what is object arrays? Object arrays. So when we are creating multiple objects, it's really hard to maintain them, right? So let's say we have something similar. Okay, I'll create a class first. After that, I'll create the object. So in my case, I'm gonna create a class called people, or maybe student, and then inside this object, we're gonna store we are gonna store the name, string name, and just the name is enough. So I'm gonna create the constructor. I'm gonna generate the constructor. Done. Yep, that's done. So let's say you're creating a object of student. So let's say it's me. Okay. So this is how we create the object. This is how we create object of student, right? We say the class name and the reference name of the object, and then we use the keyword called new. Again, the constructor student. So in this constructor, we have to pass the name of the student. So I'm going to pass it as Akzai. Yep, that's it. So after doing this, we have created our object, just one object with the reference name of Akzai. So if it's just one object, then it's easy. But when it comes to like thousands of objects, let's think like you want to create objects of us. You want to create you want to store all the student information inside your class or inside your school premises or something like that. In that case, we'll be having thousands of students, right? Which means there would be thousands of individual objects. So when it comes to thousands of individual objects, are we gonna use the same method? Are we gonna say like use the different names of each person? Are we gonna create something like this, or are we gonna do something which is way simpler? So the easiest way is to create an object and store the object inside an array. So before understanding how object array or else how to implement an object array, we have to understand how objects work. So when it comes to Java, when you're creating a variable, so let's say you have a variable called int. So these variables are getting saved inside a memory or the temporary memory, which we call. So there are two kinds of memory. One is stack, which is more like a table based, and the second one is heap. We call it as a pool of memories. Okay, heap and stack. Stack memory is more like a table structure. So what happens is it will be having the key and the value. So let's say key and the value pairs. So when you create a normal variable, something like x equals 2, then what happens is the key would be the variable name, and the value would be the value which you assigned for it. So 2. Likewise, when you create any other variables, it's going to be the same. But when it comes to an object, it doesn't happen in the same way. What happens is when you create an object, so let's say we are creating an object, we are creating a object of a student. Let's name it as John. This is our reference name, and inside it we have a variable called name, right? So the value is going to be John. Okay, so when we create a object, the value and the object doesn't save inside the stack memory. It's going to be saved inside the heap memory. So it will be saved inside our heap memory. So how do we call, or how do we reference this connection between the heap and stack memory? So that's why we have this reference name, or whenever we create an object, we give a reference name, right? So that reference name gets stored in our stack. So it's going to be John. So the reference name is John here, right? So the reference name would be stored inside our stack, and the value for that reference name would be indicating, or it would be pointing. It would be pointing. Wait, let me change its color. It would be pointing at our actual object. So when it points our actual object, it's going to be a random set of memory address or memory location. So let's compare it something like xxx, something like this. So this is why when you create an object and when you try to print the object reference, so if I say, if I just call my name like this, so this is the object reference, right? So when I run this code, you'll be seeing some random memory address, right? So this address, so this is the address of our object where it's stored inside our heap. So this particular object which we found here, wait, not this, sorry. This particular set of string is the address of my object, and this is what gets stored inside my stack, and it will be pointing at the object inside my heap. So the actual object is inside our heap, and inside our stack we only store the memory address of the particular object or particular instance of the object. Okay, so that's how objects works in Java, or that's how objects are created in Java. So now we all know this particular address is going to be unique for each and every object, guys. So if I create another object with something like Amy, so in that case this object is going to have a unique memory address. It's not going to be the same, though it's gonna have the same first starting point, but these are going to be different. So let's try creating one. Let's create another object. I'm going to say student John equals new student John, and then let's try printing this system out println John. So when I run this code, you'll be seeing both of these objects, even though they are from the same class, they are going to have two different memory addresses. So each of them, or each of these reference are pointing at two different places. So let's take my name, and let's say we have address of xxx, and this one has the address of this thing. So each of these reference will be pointing at a new thing. So what we are going to do is we are going to take this memory address, or this is our actuals, or wait, let me clear this. So now we found out our objects are stored in the heap, and inside our stack we only have the memory address, and using this memory address only we are going to access the items inside our object. So how do I say we can only access using the memory address? So let's try it. So let's try saying something like this. So you know inside your variable called John, you're only going to have your memory address. So in that case, can I do something like this? Can I create another variable with the same data type? So when you create a class, it is also known as a data type. Okay. So I'm going to say student, and let's say sample, and just give a random reference name. And I'm going to say it's going to equal to the object which I created called John. So what I'm trying to say is, I'm trying to say this John is obviously going to point at this location, and I'm also saying the sample or the variable name which we gave as sample, I want it to be the same value of John. So it's going to copy the value of John. So if then this should be having the same address, right? It's going to have student at F5 whatever the address, right? So let's see if it's working. So I'm saying it's John, and then I'm going to print south. First let's print John's address, and then let's print sample's address, sample. So let's name it as John John plus, and here sample plus. Okay, let's see if the address are the same, the memory location. So you all can see both of these has the same memory address. So which means both of these variables are pointing at the same data or the object. So now what happened is both of these variables are pointing at the same object. So which means I can use the methods which are inside our student class using this particular reference as well. For example, let's say we have something called let's say we have a get method inside this. I'm going to generate it. Get a student, yes, yep, string, yep. So let's try using the getter method. So rather printing this, I'm gonna say sample dot get name. So in this case, let's say what's the output? It says John, which means it's pointing at this which means our sample, the variable, is pointing at this particular object, and that's why it can retrieve the variable inside it, which is name, and it returns John. So you all can see, even though we have different objects or different reference name, what gets stored inside that particular reference name is just a piece of memory address. Like your, so that's what we store inside our stack. So what we are going to do is we are going to collect all these memory addresses or different memory addresses. So let's say this one has one student, it has something like student at 1 2 3, something like that. And let's say our second object has something similar, student at 4 5 6. Just imagine these are our memory addresses. And let's say we have another student named Hafsa. So in that case, let's say it has another ID called 576. So it's going to be student.576. So rather than storing each of them in a different variable, which would be consuming more and more space in our stack, we could store all of this inside an array. So this array is called as an object array. So this is what we call as an object array. Once again, when we are retrieving, or if you wanna use a particular object, you can just use indexing and get the object out, and you can use it as the normal way or reference it in the normal way. So let's try creating this. So I'm gonna create two different, or let's create three different objects. Anki new student, okay, Angie. So we have created three different objects, and then what I'm going to do is I'm going to insert all these objects inside a array. So how do I do this? So you all know Java is statically typed language, which means even if you are creating an array, we have to say the data type of that particular array. So when it comes to this, what is the data type of the array? So the data type of the array is going to be our class name, which is student. So you all have to know another thing. Whenever we create a class in Java, it's going to be a non-primitive data type. So you all might have learned primitive and non-primitive data types. So this, whenever you create a class, it's going to be a non-primitive data types. Similar to strings. So string is object, right? Why do we say string with a capital S? Since the reason is because it's a non-primitive data type. When it comes to integer, we just say int, right, with a simple I. Or when it comes to float, even we just say float with a simple f. But when it comes to a string, we use a capital S. The reason is it's a particular class. We are saying string is a separate class. So let me just try this. So when I click this and when I try to browse over this, it points me at a different class. And when I click this, it shows a class file of string. So this is the class file of string. So how do I access it? You just scroll over the variable while pressing Control. So if you press Control and scroll, you'll be able to click this. And when you click this, you all can access the class file. Okay. So likewise, our student is also a data type now. So now we can create an array, right? So we're gonna say student array. Let's give a reference name for this array. Let's say students, and we are gonna say it's equal to, and we're gonna create the set of elements. Inside this, what we do is we are gonna pass the objects which we created. Sorry. The first one is Zion, and then John, and then Angie. So bypassing, wait, there's some error throwing here. The reason cannot resolve. The reason is there's a dot here. It should be comma. All right. So by doing this, now I have created an array of objects. So what do we have inside this array? We have different objects, right? And that's why we call it array of objects or object arrays. So now what we can do is we can use this object array and even use the methods inside it. So for example, when you're pointing at element, you should be using index number, right? So let's say I want to point at John. So what would be the index of John? It's going to be 1. So starting it's going to be 0 and then 1. So I'll say 1, and then let's try if we can use the getter method. So when I type dot, it suggests it by default suggests us the get name object. So likewise, we can use any methods inside the objects using the reference. So this is going to work similar to the addresses. So let's try doing something like this. Let's print the object address of John, and then let's try printing the object address of students index 1. Okay, so we're going to do something similar. So we're going to say students array, the students array which we had, and inside the students array we are going to say print the address of the object in the index 1. So what which object is inside our sorry so inside our array in the first index we have John, right? So both of these should be printing the same address, right? So let's see if it's the same. So let me run this code and y'all can see we are getting the same thing. So let's see if we can use any methods which is inside our student class. So I'm going to say students.1.get.name, and let's say if it's working without throwing any errors. Yes, it works. It says John. So the name of the person is John, right? Maybe John Pereira. So when I run this, it's going to say John Pereira. See, it works. It works perfectly. So this is how you use object arrays or create object arrays and use them. So when it comes to like 100 objects, let's say you are creating 100 objects, then you don't have to like create you don't have to like create 100 different type 100 lines of code. Rather, you're gonna have a single object and loop it 100 times. So let's try doing it. So what I mean is, first of all, let's create the object array. Okay, so I'm gonna say student. So it's going to be array. So I'm gonna say this, and let's give a name for our array as students. New int. So whenever we create an object, whenever we create an array, either we have to say the elements inside it, or else we have to say the number of items which we are going to have inside it. So now I'm going to say the number of items, since I don't know what are the elements which we are going to place inside. So I'm going to say I'm going to have 5 elements inside it. Okay. Wait. It shouldn't be in a new int. It should be new student once again. Student. Yep. Now it works. So after that, what I'm going to do is I'm going to have a simple follow. Inside that, I'm going to say int I equals 0 while I is lesser than 5. I want to run this condition, and I plus plus. So inside this, what I'm going to do is I'm going to ask input from the user and then assign it to the students for the student object's name. Okay, so we're going to ask a user input. So let's create a scanner class as well. Scanner scan equals new scanner, and inside this we'll be saying system.in. All right, we're done with this. So let's say south enter student's name. So let's say this, and then we are gonna get the student name. String name equals scan dot next. So after getting the student name, we are going to create the object. So we are going to say student. We had to again create a reference. So let's keep that stored equals new student. And inside this, we are going to pass the name which user gave. So it's going to be name. So this variable name is the name which we get from the user, or the input which we get from the user. So after that, we are passing it. And then what we are going to do is we are going to create the object, and then we are going to insert it inside our array. So how do I insert it? So I'm going to say I'm going to call my students array, and I'm going to give the index as I. The reason is at the start the i's value is going to be 0, and during the first iteration it's going to be 1. Likewise, it would be going until 4. Okay, so I'm going to say students I is equals to the current student object which we created, which is stud. So after doing this, let's see if it's working. Let's try to like print all the student names which we created. So let's have another for loop. That's the easiest way, or else I should be typing 5 lines of code. I'm gonna say we can either use a for each loop or else a normal traditional for loop. Let's use a traditional for loop. I'm gonna say I could just copy this, Control C. Nothing complex. I'm trying to iterate through each of these items and print the value. So I'm going to serve student I dot name dot get name. So what happens is it's going to, let's assume that we have 5 different, we'll be having 5 different objects, right? Let's say first object is X, Y, Z, A and B. So during the first iteration, i's value is going to be 0, so it would be pointing at this object. And during the second iteration, i's value would be 1, so it would be pointing at this object. Likewise, during each and every iteration, it's going to point at a new different object, and then it's going to call the dot get name method, the method which we created inside our array, sorry, inside our class. So let's try running this. Let me cancel this. Okay, so let's try running this. Okay, it's asking for the student name. So let's say John Silva. Wait, this is cause of next line. This should be working. Let's go try. John Silva. Yep, it's working. So John Silva, the second one is Angie. The third one is Hafsa. The fourth one is Peter. Fifth object is Steve. Now let's say if it's working properly. So you all can say after typing all the names, what it does is it creates object out of it. So you all have to trust me, it's creating object. So if you all don't trust me, I could remove this dot get name method and I could just print the memory address or the memory address of each of those objects. So if I run this again, it's going to print the memory address. So now we are getting the names, right? So let's try printing the memory address. So if we have created an object successfully, like properly, then it should be returning a memory address. So let's say Angie, Hafsa, Peter, Steve, John. Yep. See, we have 5 different unique addresses. So each of these are representing a unique object. So that's how objects works. And I think that's all we have. Yep, that's it. So we are done with objects as well. And now we have a small exercise for y'all. So I'll be sharing the link. Nijan, can you share the link in the group? So Nijan would be sharing a GitHub link. So inside that we have a question. GitHub. Let me show it. Okay, so the question is, my repository is, give me a minute.
It's the banking system. Yeah.
Yeah, I'll share the link here as well. It is an open repository, so you all can have a look at it. So, so SRC. So here we have 2 classes. One is the main class, and then we have a people's class. Okay, people, yeah, person class, not people, a person class. So what we are trying to do here is we have a simple banking system. So this banking system has 4 options. The 4 options are registering a customer, and then saving the customer details to a text file, and then retrieving the same customer details. So I told you, right, when we are running a program, if we store the details in a variable, it's going to be temporary. So we want it to be permanent. So that's why we are storing it to a text file. And then what I want you all to do is, so let's say we have 2 customers in our current application, and then we are closing the application after saving the file. So after that, when I open the application again, I want to have the previous customers which I had, the customer information which I had previously. So for that, what you all have to do is you all have to read the file again. So you all have to read the file which you all stored, and then you all have to try to implement like the reverse way of writing. So what you all have to do is you all have to read the file, get the data, and create the objects. So that's what you all have to do. So just give a try. If y'all can't, we can discuss it here. And as the last part, what you'll have to do is you'll have to get each customer's account balance and order it in sort it in ascending order. So for now, just do the question 2 and 3 as a homework. You all can try this. Okay. So for now, I want you all to do only the second and third one. So these are the tasks. The task one is implement storing the customer data to a text file. The second task is retrieving the customer data previously stored in the text file and resume the applications. So I have given the base application, everything. You all don't have to type it from the scratch. We have the menu. We also have the register method, which would be registering each and every persons. So what we do is we get the person's name, and then we are asking for the person's account balance, and then we are creating an object of it. So we are creating a person object. So this person class has two properties inside it: the name and the balance of the person, the account balance of the particular person. Okay. So after doing that, what I'm doing is storing it inside a person or object array. Okay. So what I want you all to do is I want you all to type your code here. Implement the file writing method here, and also after that implement the reading method here. So all of these are here. You all can just click on this download button and download the file. Make sure you all download both the files, not just this, but the person class as well. So inside our person class, we have two properties, name and balance. We have the getters and setters for each of them. That's it. So you can download the whole file and run it in your application. I'll give you all around 15 minutes to do this, and that will be enough. Um, 15. Let's yep. Good luck. I'll share the link in WhatsApp as well. Let's discuss this. Okay. So I'm gonna open the answers. Open. Okay, so this is the answer. So I'm not gonna do it again. I'll explain and show how it's done. To write the data, so we created an object of file writer. Okay, so after that what we do is, so every time when we create an object of a person or person in this class, so let me open this. So we have this class called person, right? So inside this person class, there are only two properties, which is name and balance. So whenever we create object of person, these person objects are stored inside the heap memory, and those memory address are stored in our stack. So what we do is we take those memory address and we store it inside our object array. So this is the object array which we have created, the person, and the name of the array is simple p person. Okay. So you all can see here we create an object of person, and then what we are doing is we are storing it inside the person. Why have I given it as customer count? The reason is uh, every time when we register a person, I'm going to increase this count by 1. So this is basically like the index of how many customers I have in my application. Okay, so what I do is I store it inside my array and then increase the count. Okay, so that's how the registration is done. So when it comes to saving the details, you all know, even though, so let's take this. So even though here I have initialized the array by giving the size of 50, I have initialized the array by giving the size of 50. But during, like, when I'm running the application, like during the first time itself, I won't be having 50%, right? There are less chances to have 50 customers. So let's say maybe we have like 5 or 6 customers or just 2 in this case. So when we have two objects inside this, so this is being recorded. The number of objects is being recorded using that customer count. Oh wait, is it the same name? Yes, customer count. So whenever we create an object, we increase the count by 1. So if there are two objects, then it's going to be the count is going to be 2. And the rest of the objects or the rest of the spaces, the value of the spaces would be null. Why do I say null? The reason is whenever we have a non-primitive data type, the default value for this non-primitive data type would be null. Okay, so if we have a array of person, and if we didn't store any objects inside that person array, then it's going to be null. The whole array would be having 50 null values. That's all. Okay, so what we are doing here is we are using a for loop. Oh wait, not this, sorry, my bad. So when we are writing the data, we are using a for loop and we are checking. So okay, before using the for loop, what we are doing is file writer. So we are using a for loop and we are saying the condition should be starts at 1 and it should be stopping at the customer count. So let's say we have 2 customers, then we only have to write these two, the values of these two, right? There's nothing to write rather than this. So if your object is null, then there's nothing inside this object, which means there's none existing inside this object. So what we do is we use this condition called customer count. So we are saying while your count is lesser than the customer count, or while I is lesser than the customer count, I want to run this set of instructions. So inside this, again, we are just checking if our person's the particular objects or the index value is null. So if it's null, then we are not going to do anything. If it's not null, so you all can see I have used a not equals to operator. So we are checking if the current element of that person object is not equals to null, then what we are doing is we are using our writer and writing the person's name, and we are giving a space here. So we are writing the name and giving a space. After that, again we are writing the person's balance and we are running it to the next line. So we are asking the cursor to move to the next line. So this is how we are writing the data inside our file. So for example, let's say I have a person called Angie with balance of 700. So in that case, inside our file, it would be saved like this. It's going to save the person's name, leave a space, and then store the balance. After that, the cursor would be moving to the next line. So that's how this program or this code works. So after that, I'm closing the writer. So that's something you have to do. So this is how we save the data inside our text file. So now let's see how to retrieve the same data which we stored inside our text file. So before that, let me try running this application and storing few data. Okay. So let's say NG 700. So the second customer is going to be John 600. Okay, so let's save this to the file and then let's exit from this code. So I saved it and I exited. So let's see our customer. Oh, let me open it file. Oh, sure. So now you can see it's supposed to be Angie. So we have Angie and then it says 700 and John it says 600, and can you all see it's showing number 3, the line 3. Even though we don't have anything, it's the cursor is at line 3. The reason is we have next line over here. So we have told go to the next line. So let me close this. So save data here. After we type the balance, after we write the balance inside our file, we are saying go to the next line. So that's why the cursor is in the third line. Okay. So this is how we write the data. So now when we are retrieving it, what we do is we are going to take each line and then we are going to separate these two data. So this is our name and this is our account balance, right? So we are going to split these two data and then we are going to recreate these objects. So we have to again create the person objects. So we have to create an object for Angie and then we have to store the information inside it, such as the name and the account balance. After that, what we have to do is we have to again insert it inside our array. Why we are doing this is, so the reason behind this is, so let's say, so the first time you run the program, so let's say running first time. So when we are running the first time, you are creating objects of Angie and John. So these data are saved in our stack, and soon as we terminate our program, these data are going to be erased as well, right? So that's why we store our data in a text file. So after storing it in our test file, we have to retrieve this and again load it into our stack or create the objects, because without the objects we can't work inside our program, because our application works on based on the objects or the methods the object has. So what we do is we retrieve the data and then we are going to create the same object again. We are going to create the person object again and store it inside the array. So that's what we are trying to do here. So y'all can see, first I'm checking if there's any next line in my text file. Yes, we have a line inside our text file. So if we have a line, we are going to read the data and assign it to a variable. So after assigning it to a variable, what I'm doing is I'm splitting the data by using a space. So y'all can see whenever we enter a data, we are using a space in between the name and the balance, right? So that's a breakpoint which I'm going. It can be anything. It can even be a minus sign or else a colon or anything. So in my case, I'm giving a space. So I'm splitting the data by space. So after splitting, what happens is we'll be having an array of strings with Angie, and 700 as string. So this is how the data array would look like. Data array. So this is how the data array looks like. So after that, what we are doing is we are saying we are creating a new object of a person, and we are saying the values are going to be, so the first parameter is going to be the name. So for the name, it's already in string. We don't have to convert. We can just enter it. But when it comes to the account balance, we have to make sure it's in integer, right? Or else we can't do any calculations. So for that, what I'm doing is I'm taking this particular value and converting it to an integer. Okay. So I'm converting it to an integer and then creating an object of it. So after I create an object, what I'm doing is I'm straight away storing it our um, inside our person array. Okay, so you can break this part into two lines, but just okay, let me try breaking this part. So y'all can do like this as well. So I could say person customer equals new person and create the object, and in the next line you all can say equals customer. So both are the same style. It's just the less number of lines and it's easy to read. Okay. So this is what I have done in the previous way as well. Just assigning straightly inside our array itself. After that, again we are increasing our customer count. Okay. So whenever there's a next line, we are gonna take the object, we are gonna split it, and then create a new object out of it and store it inside our object array. So this is how you read the data and make a process where it's gonna resume from the part where you left in the last time when you ran the program. So by doing this, let's say now after doing this, you closed your program. Clear all drawings. Yeah. So this is during the first run, right? So after you close it, in the second run, when you run this, you want all these objects to be backed in the same way you created, right? So to do this only, we are again creating the objects and storing it inside our array. So by doing this, what we are trying to do is we are trying to get the previous state of our application, or trying to run in the way where we can access the previous data which we had while running the application the last time. Okay. So after doing that, you have to close your reader and wait. Yeah, you have to close your reader. So that's how you read the file. So when it comes to the sorting method, I have given two methods. There are two possible ways you all can do it. One is switching, like taking all the balances. So let me explain it. So you all know the balancers are inside each object, right? Each object, let's say ng, or let it keep it as A and B. So each object has a name and a balance. So this also has a name and a balance. So what you all can do is either take the balance out of all the objects and store it in a particular array, and what you do after that is you're going to sort this array. You're going to sort this particular uh, array. Let's give a random value 600 and 300. So you're going to sort this array. After sorting this array correctly, so you'll be implementing bubble sort. So after sorting this array, what you'll be doing is you're going to find the object which has the same balance amount. So you're going to find the object which has the same balance amount. So which object has the same balance as 300? B, right? So then you'll be printing that object first, of that this one. So this method is technically correct, but then again we don't use this method, or we don't prefer this method. The reason is, let's say two object has the same balance, or yeah, let's say both of them has the same balance. So in that case, it's going to be stored like 300 slash 300, right? So there should be a preference which one comes first. So it's mostly like we use a method called first in first out. So the first customer who gets registered inside our application should be the first customer who's displayed. So when it comes to that way, this method or this algorithm won't be working properly. Though it shows everything correctly, in the backend it won't be working properly. So we don't recommend using this one. Rather, what y'all can do is, y'all can imply this method rather than checking. So rather than doing this additional step where you'll be taking all the balances to an array, what you're going to do is, you're gonna compare the balances of each object and switch the object itself. So now you all know we have a person object, right? So what we are going to do is, we are going to sort this person object itself using the balances. So let's see how we are doing it. So what we are doing here is, we are saying, so method one retrieving all so this is the method which I told you previously, where you'll be creating get person. Give me a minute. Con name. Yeah. So y'all can read this. So retrieving the account balance from all the customers, entering it inside a new bank balance array, and then sorting the array. So this method is, it works fine, but still it's wrong. Okay. So the best way to implement this is this one, the method 2. So what we do here is, we are going to have the bubble sort algorithm. So let me um, wait, there's some mistake which I did. Correct. Okay. So what we are doing here is, we are performing our bubble sort algorithm. So to perform bubble sort algorithm, we need a nested folder, and inside it, what we are doing is, we are taking our person object. So we have this person arrays, right? So inside this person's array, we have unique objects. Let's say A, B, C, D. Let's just name it out. So A, B, C, D. So what we are doing is, we are taking the object A, and using the method called using the getter method to get the balance. So we are getting the balance and comparing it with the next object's balance. So you're getting object A's balance and checking if it's greater than object's B balance. So if it's greater, then what you have to do is swap it, right? So that's what we are doing here. So we check if the objects balance are greater. If it's greater, what we do is, we move the object, like we swap them. We swap each and every objects. So this is way easier to do, and this is the correct way of doing it. So that's what I have done here. Once again, see, this temp variable is holding person object, right? Which means this variable's data type should be a person, and that's why I have given the data type as person here. Okay. Make sure, guys, y'all do it properly, because when handling object arrays, and when you're trying to retrieve a object through your object arrays, again you all have to create a reference of the same object. You all can't have a string data type or integer data type. It should be the person data type. Okay. So after doing that, this sorting algorithm works. So let's try running this program. Yeah. So what I'm going to do is I'm going to create two objects, ng 751 Paul 526 John 200, let's say higher value 900. Okay, so now I'm going to save this to a file. First of all, save. So after saving, I'm going to exit. So you all can see the data here. We have Angie, Paul, John, the values here. So now it's not sorted, right? 751, 526, 900, it's not sorted. So now I'm going to run this application again. So when I run this again, now it doesn't have this object, or it doesn't have the data of Angie, Paul, and John. So how do I say it? So let's try displaying. So when I display, when I use the option 4, it doesn't display anything. It just goes to the menu back. So what I'm trying to do here, what I'm going to do now is I'm going to retrieve all the objects, or all the objects which we created and saved it. We saved it inside a text file, right? So we are going to retrieve those. So I'm going to use my option 3, which is going to retrieve the data and create the objects again. So now we can say successfully loaded. So now let's try to print it. So when we are printing it, it's going to sort it as well. So see, this is where we are printing the object details. So before printing it, what we are doing is we are sorting the array. So let's try pressing 4. And now it's sorted. See, 526, 751, 900. It's sorted in ascending order. So this is how you sort your arrays or your data, basically. So do you guys have any doubts in this part? So if y'all have any, y'all can ask it now. And also, there were few questions on your coursework. So we made a sample code where we can show you. Hold on. Until I load it, if y'all have any doubts, y'all can ask it. Okay. So this is the example. This is your coursework as well. So I can't show the code. So the questions we had was, um, do we have to implement student management class, student class, and module class? Yes. You all need 3 different classes to record all of this. So when it comes to a student object should be storing the student name, and the modules, the particular student too. And when it comes to the module class, it should be storing all the module marks. So you all have 3 modules, and you all should be storing all the marks inside that module class, right? So that's why you all need 3 classes. Objects from student modifier and stored in single dimension. Okay. So the functionalities in your coursework description, it's not mentioned like in depth, though it's mainly like if it's check available seats, it's going to it's either going to say the number of seats available, or if you all have any representation, or if you all have any Java effects implemented inside this, then you all can use a UI and show it. So since it's just a basic application, I didn't implement any UI. It just says how many seats are available in the system. So there are hundreds available seats. So every time we register, it's gonna get lesser. Okay. So when it comes to registering a student, we'll be getting the student ID or the unique address, the name, and the marks of each modules. So it's going to be 78. So like this, you all can register all the students inside your file. So after registering it, you all should be able to delete the student as well as find a student or store the student data in a particular text file. So again, we are implementing the same thing which we did in our previous question. You just have to store the file, you all have to store the details to a file and retrieve it and resume the application. So it looks something similar to this. Let's say I'm adding another student. Let's W, say John, and 54. Yeah. So if I store the data to the file now, and let's exit this code. I'm gonna say 0. Yeah, exited. Hold on. Let me show you. So this is how it looks inside our student data.txt. I hope you all can see it now. So this is how I'm storing it. So y'all can use a way different method. Y'all can store it in a very in a way better or nicer way. So here what I'm doing is, first half I'm storing the student ID, leaving a space, and then storing the student name, and again I'm leaving a space, and then I'm storing the student marks. So each of these marks are separated by a colon. Okay. So when I'm retrieving the data, what I have to do is I have to read the line, split it by the spaces, and then create the object again. Okay. So that's all you all have to do. So if you all are running this application again, let me hold on. So when we run this application again, we should be able um, to load the data from the file which we stored. So now it's loaded, though it doesn't show anything in my application, though it's loaded. So let's check the number of seats available. So we had 2 students registered here, right? So 100 minus 2, it should be 98 if it's working properly. Let's check. So it says there's 98 available seats, which means it's working properly. So even I think I implemented the delete method as well. So we should be able to delete the students, and that's basically how your application should work. So this is all you all have to do. It takes like less than a day to do this. So give a try, and if you all have any doubts, you all can message us or contact us. So is there any other doubts other than this? Maybe on any other topics? Anyone? Okay, seems like no one has any doubts. So if so, we can end this session. Thank you for joining, and if y'all have any doubts, y'all can reach us out. Thank you.